Hi ladies, this is Mrs. Blaufuss and this is lesson 5.5. It's properties of special parallelograms. So we've already talked about parallelograms, we talked about trapezoid, and we talked about what some special parallelograms are. And so those are the squares, rectangles, and rhombuses. So now we're going to discover some special properties that each of those hold. So if you're following on your note sheet, the first step is to construct a rhombus using a double-edged straight edge. You can use a ruler for this, or your student ID would work just fine too. So I'm just going to show you what I mean by construct a rhombus. So using your straight edge, trace along the top of your straight edge to make a line, and the bottom of your straight edge to make a line, and then just turn your straight edge. And do it again. Trace along the top to make a straight line. And along the bottom. Alright, so if you look at this parallelogram that you drew, you know it's a parallelogram because you used a straight edge in both sides of it. So assuming both sides of your straight edge are parallel, then both of these pairs of lines are going to be parallel. Alright, something else you know about your straight edge is that if they're parallel, then it's the same distance between the top and the bottom on both sets. So all four of those sides are congruent. So you've just constructed a rhombus using your double-sided straight edge. Now I want you to look at your protractor and use your protractor to measure the intersection of the diagonals of the rhombus that we just created. So you're going to have to use on your straight edge to, first of all, make your diagonals. So here are the diagonals of our rhombus. And use your protractor to measure where those intersect. Alright, so make sure that you line it up perfectly, and if you look at your protractor, you should see that this is a 90-degree angle for all of those angles at the intersection. So you can go ahead and mark your diagram, 90 degrees. And then if you look below, you should, based on those observations, complete those conjectures below. So let's look at these conjectures. It says the rhombus diagonal conjecture. The diagonals of a rhombus, if you look back at your diagram, these two diagonals, we discovered that those are perpendicular. And something else we can discover, if you look at your hint on here, it talks about their lengths. So let's look at the lengths of those diagonals. Now, you're not going to find that they are congruent because they're not. But let's just use our ruler. And I'm going to use 9 centimeters, but everyone's rhombus is going to look a little bit different anyway. So here's my ruler. If I look at this, the whole thing, the whole diagonal, is almost 8 centimeters. And where they intersect is almost 4 centimeters. So these two are the same. Okay, these two segments here. The two parts of my diagonal are the same. Now let's see if that's true with the other part. Move my ruler over here, measure my whole diagonal, and then see where they intersect. So my whole diagonal is about 2 1/4 or so, 2 1/4 centimeters. And then where they intersect is just a little bit over 1.1 or 1.2. So same is true here. These segments are the same. Now my diagonals are not congruent, but the diagonals bisect each other. So in your conjecture, the diagonals of a rhombus are perpendicular, and they bisect each other. So then the last step is the diagonals and the sides of the rhombuses form 2 angles at each vertex. Let's look at each pair of angles. And then we'll complete the conjecture based on our observations. So going back here, now just looking at this, if I remember the properties of my isosceles triangle, I've got a couple isosceles triangles here. But just for fun, you can actually measure those angles too. So let's measure this angle first. And the whole angle is about 32 degrees. And if I look at my diagonal, so here's my whole angle, 32 degrees right about here. Then if I look at my diagonal here, it brings me at about 16 degrees. So what conclusion can I draw here? You can measure all of those angles, you're going to find the same thing. But that diagonal bisects each of my angles. So the diagonal of a rhombus bisects the angles of the rhombus. All right, now let's look at properties of another special parallelogram, which is a rectangle. So you've got a grid on your note sheet. Use that grid to draw a rectangle. So it doesn't matter where you draw it, but follow the grid line so that it forms a rectangle. Make it so it's not also a square, so that it is just a rectangle. And then let's draw in our diagonals. So if you look at the properties of a rectangle, we know that those two sides are congruent and these two sides are congruent. So now let's use our ruler, or you can use your compass, to compare the lengths of the diagonals. So we used our ruler last time, so let's use our compass this time. I'm going to line this up so that I can measure the length of my diagonal. Alright, so here's one diagonal. Now if I don't change my setting on my compass and I look at my other diagonal, that is the same exact length. So whether you use your ruler or your compass, you should find that the diagonals of a rectangle are congruent. And also, the that they bisect each other. So the length of this part of the diagonal and this part of the diagonal are the same. Alright, then lastly, let's look at squares. Now, we can combine the properties of the rectangle and the rhombus to get the properties of a square. We're not going to actually test this. But a square is a rhombus because it's a parallelogram that has 4 congruent sides. But a square is also a rectangle because it's a parallelogram that has 4 congruent angles. So, if we were to redefine square using rhombus in our definition, we would say that it's an equiangular rhombus. And because, again, a rhombus is a parallelogram with 4 congruent sides, but a square also has 4 congruent angles. So it's an equiangular rhombus. And then also, it's an equilateral rectangle because it has all the characteristics of a rectangle, but it also has all 4 sides congruent, not just 2 pairs of congruent sides, all 4 sides are congruent. So if we look at the properties of the diagonals between a rhombus and a rectangle, for a square, since it holds both of those characteristics, the diagonals of a square are congruent, like in a rectangle. So I'll just write this as a side note. So they're congruent like in a rectangle. They're perpendicular. Like in a rhombus. And they bisect each other. And bisecting diagonals is true in both. Alright, so now that we have all of these special characteristics of special parallelograms, let's look at this extra example. So ABCD is a rectangle. Let's right away mark what we know about rectangles. Where opposite sides are congruent. And we also know that all of the angles add up to 90 degrees. Alright, now we've got the diagonals of a rectangle. So what we know about the diagonals of a rectangle are, first of all, that they bisect each other. And second of all, that the diagonals are congruent. So that means all 4 of those parts of the diagonals are congruent. So now if you look at your diagram, you have 4 isosceles triangles. 2 of them are congruent from side, 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 and the other 2 are congruent from side, side, side. So this first one here, this triangle, and this triangle are congruent. This triangle and this triangle are congruent. Okay, so now we're looking for the measure of angles x, y, and z. So let's start by looking at this triangle DEC. And there's a number of places you can start, but let's just pick a point. Let's start here. So if this is an isosceles triangle, and this angle is 22 degrees, then this angle is also 22 degrees. Now we can use the sum of our triangles conjecture, and we know that the vertex angle then, where E is going to be 180 minus 22 minus 22. So that's 180 minus 44. So that gives us 136 degrees. Now this angle and angle Z are vertical angles, so angle Z is also 136 degrees. Right, so angle Z is 136 degrees, it's an isosceles triangle, so both of these have to be 22 degrees. Alright, so next we know that in a rectangle all four of the angles are going to be 90 degrees. So now we can figure y. Y is 90 degrees minus 22. So y is 68 degrees. And then lastly, now that we have those, and we know that that angle AXD is an isosceles triangle, we know that this other base angle is also 68 degrees. So y is 68, the other base angle is 60 degrees, and we know that they have to all add up to 180 degrees. So 68 times 2 is 136, and if we subtract that from 180, we get 44 degrees. Now there's another way you can do it too, because if you realize that x and z form a linear pair, then you could take 180 minus 136, and you would again get 44 degrees. All right, so please see your note sheet for your homework assignment and come see me if you have any questions, and we can go over them together. All right, thank you.